Hey guys, welcome back to Techogram. Today we're going to learn the fourth method of CPU scheduling, which is time slot method. So let's get started. So first let me write the question. This method is also called round robin method or round off method. So this is our question. As usual, first we have to make a Gantt chart. Now the Gantt chart will always be start from 0. So as usual, start the Gantt chart from 0. And now what is a time slot method? The time slot method, there will be time slots in the Gantt chart. For example, in the question it will be given that what is the size of the time slot. So for example, the size of the time slot is 2. So we will take time slot 2, and then what you have to do, first we have to see which process arrived. It's almost like the shortage of first primitive method, because we have to replace a process when once a time slot is over. So what we have to do, first we will see which process arrived on 0. So you can see we have to look at the arrival time, and you can see on 0th time the P3 process arrived, so we have to start the 0th. And because this is the time slot 2, we can only take the process P3 to 2 milliseconds. So now this 5 will become 3 because we have taken the 2 here. Now we are on 2, and now you have to see which process to take. So you can see on 2 all these 3 processes arrived, because these arrived on 0, this on 1 and this on 2. And now we have 3 processes, P1, P2 and P3 with the burst time 3, 2, 3. So now what we will do, you have to look from the upper side and see which process can be taken. So the P1 process can be taken because there are 2 time slots. So then again we will take the P1 and then move it by 2. So 2 plus 2 will be 4, and this will be 1 because 3 minus 2 will be 1. Now we can see that after the P1 the process is P2. So now we have to take again the same time slot, which is 4 plus 2 will be 6, and then we have to write the P2. The burst time of the P2 is 2, so this will become 0. Now this process is over. So we have only 2 processes remaining. So the method in time slot is that once you have taken all the process, you have to again take the same series. So for example, we have taken P3, P1, P2. So now we have to take again P3, then P1, then P2 if possible. So then because P2 there are only 3 processes, again we will take the P3. And now because the time slot is 2, 6 plus 2 will be 8. Now this 3 will become 1. And then again move the time slot. And now you can see this one is remaining and the P1 is remaining. So because after P3 the P1 is here, you have to write the P1, and there is only 1. So even if the time slot is 2 but the available burst time is 1, so we have to just take it by 1. So now the 8 plus 1 will become 9, and P1 is also over because this one will become 0. And now the only process remaining is P3, because we cannot take the P2 because P2 is already over. So now we have to again take the P3, and the P3 is only 1 millisecond remaining, so this will become 0 and this will become 10. So this is how we have made our Gantt chart. Now we have to find the start time, waiting time, finish time and turnaround time. So as I said in my earlier videos, if you have not checked out the previous video, go check them out. You will get a better understanding of this. So always for the start time you have to look from the left side. So start time will look from the left side, and for the finish time look from the right side. So first we will find the start time. So you can see the first process P3 which started on 0, so directly write 0 below the start time. Then the next process is P1. So P1 started on 2. So you have to write P1 started on 2. And now the P2 process which started on 4. So write 4. Now to find the waiting time, the formula for waiting time is finish time subtract starting time. So for this waiting time we have to first find the finish time. So from the right side, P3 finished on 10, so write 10. Then you can see P1 which finished on 9, so write 9. And then we have to find the P2. So here is the P2 and it finished on 6. The process P3 is divided into 3 parts. The process P1 is divided into 2 parts. Only the P1 is executed in a single part. So we can find the waiting time just by directly calculating 6 minus 4 will be 2. But for the P1 and P3 the formula will be a bit different. So first we will find P1. If you want to directly find the waiting time of P1, what you have to look, you have to see the first end of the first part. So the P1 ended on 4 and the next part of P1 started on 8. So you have to subtract this by this. So 8 minus 4 will be 4. So write 4 here. and then do the same thing by P3, because there are three parts of P3. First, what you do, you have to do it 2 times. So the first P3 is here and it ended on 2, and then the P2 started on 6. So 6 minus 2 will be 4, and then this P3 ended on 8 and this P3 started on 9. So now 9 minus 8 will be 1. So you have to add both of these times. So 4 plus 1 will be 5. So the waiting time of P3 will be 5. Now for the turnaround time, the formula is finish time minus the arrival time. So finish time minus the arrival time. 9 minus 1 will be 8. 6 minus 2 will be 4. And 10 minus 0 will be 10. Now in the question it will ask that find the average waiting time and average turnaround time. So to find the average, first you have to add all this. So 5 plus 2 plus 4 will be 11. 5 plus 2 7, 7 plus 4 11, and this will become at plus 4 12, 12 plus 10 22. So now to find the average waiting time, take the sum of the waiting time, which is 11, and divide it by the total processes, which is 3. So 11 divided 3. So the answer will be somewhat 6.67 round off, so millisecond. And to find the average turnaround time, 22, and because take the sum of the turnaround time and divide it by the same processes, and the answer will be 7.33 milliseconds. So this is how you can find the average waiting time and turnaround time using the time slot method in CPU scheduling. Hope you like the video. If you like the video, press the like button. If you have any question, comment, query or suggestion, leave that in the comment box. Subscribe for more. Bye.